With this video then, we're going to look at another aspect of trigonometry. We've already looked at Pythagoras' theorem, but this is going to look at sine, cosine and tan. Just like with Pythagoras' theorem, this is going to apply only to right angle triangles. There are certain things that we can use sine, cosine and tan with on triangles that aren't right angles, but for foundation, and of course higher tier have to know this as well, the principle with right angle triangles is all we need to know. So here we've got a right angle triangle. What we need to be able to use sine, cosine and tan on a right angle triangle are two sides, any two of the three that we have written at the side. So we need two sides, or a side and an angle, in order to calculate one of the missing factor. So if I've got a side and an angle, I can work out the missing one of the other sides. If I've got two sides, then I can work out an angle, and so on. And note that this doesn't include the right angle. So we've already mentioned that the slope inside of a right angle triangle is known as the hypotenuse. But in relation to sine, cosine and tan, we refer to the side that is opposite to the angle that we're working with, either because we're trying to find it or because we know it, as the opposite, unsurprisingly. And then the side that it's next to it is known as the adjacent. So with any triangle we're working with sine, cosine, tan, we have the sloped side, the hypotenuse, the angle that is the side that is next to the angle we're trying to find, or that we have, called the adjacent, and then the side that's opposite it, called the opposite. And you'll see why it's important to remember those and how to label each side as the opposite, adjacent and hypotenuse. So in this example, to illustrate how we use sine, cosine and tan, we have given the measurements. The opposite is 3 centimeters and the adjacent is 4 centimeters. And if you remember, we actually looked at this example in Pythagoras' theorem, where we knew the hypotenuse had to be 5 centimeters because 3 squared plus 4 squared, 9 plus 16 is 5 squared, 25, as Pythagoras' theorem tells us. So with what sine, cosine and tan are forms of calculation, a way of manipulating and changing data. Now, for instance, the same as if we say we're squaring x, or if we are cube rooting x, we can say that we are sining x or cosining x, and remember that x is a number, so we might be signing 0.5 or something. Now luckily we don't have to do any sort of calculation in relation to working out what sine 0.5 is, because the calculator will do this job for us, and this only comes up in the calculator exams. So make sure you've familiarized yourselves with a scientific calculator so that you know that how to press sine and then a number in order to work out sine of that value, or cosine of that value, or so on. Notice as well, in the cosine is often written as cos, so we've got sin, cos and tan, even though really they're sine, cosine and tan. Now these sets of equations tells you what the sine of that particular angle, x is representing an angle, should be equal to. So for instance, if I took the sine of the angle that I'm working with, it will be equal to the opposite side divided by the hypotenuse. If I want to find the cosine of an angle I'm working with, it's equal to an adjacent of the hypotenuse. Now remembering these can be somewhat tricky, but we use a little acronym. Oscar had a heap of apples. So as long as you can remember the sine, cosine and tan, we've got Oscar opposite had hypotenuse. And then on to the cosine rule, A adjacent heap hypotenuse. And then finally onto the tan rule of opposite apples adjacent. So remembering that Oscar had a heap of apples rule, if we were trying to find the angle down here, the two sides we've been given are the opposite and the adjacent. So it's not the Oscar had the opposite and a hypotenuse. Moving on, we look at the next one. Well, that's the cosine rule is adjacent and hypotenuse, so it's not that one. We're left with the of apples, opposite and adjacent with the tan rule. That is the rule we're going to be working with. So we know we're working with tan, the angle, is equal to the opposite over the adjacent. The opposite is 3 and the adjacent is 4, so tan the angle is equal to 3 divided by 4, or 0.75. And now, how do we get the angle on its own? Now remember what I said about tan or sine, cosine and tan being kind of like a square in or square root in. To get the number that we're squaring on its own, you do the opposite, you square root it. Now, there's a similar sort of thing in sine, cosine and tan. Each of these has an opposite and they're called inverse sine, inverse cosine or inverse tan. So if I've got tan, the angle x on the left side, if I did inverse tan of it, it cancels out the tan and I'm left with x on the left. But I've also got to do inverse tan to the number on the right, because as we know with algebra, whatever you do to one side of the equation, you do to the other. And as you can see, this inverse tan is written as tan with a little -1 up by here. So to cancel off the tan on this side and be left with just the x, I do the inverse tan of tan x, and I'm left with x. But that means I've got to do the inverse tan of the other side, leaving me with inverse tan 0.75. Again, this is on your calculators. Usually you have to press shift and the tan button, but make sure you can find it. So when you type in your calculator inverse tan 0.75, you will get the value 36.87. And make sure again you're working in degrees, not in radians. Radians is another type of measurement in angles, and it'll give you the wrong answer. So if you don't get 36.87 when you're trying this out, you're probably working with radians, and you have to look at your calculator how to there should be a button to change it into degrees. So that's how I've worked out the angle that we're working with by here. I had two sides. I used the opposite over adjacent, the tan x, tan the angle rule, and then used the inverse tan when I had the number. Let's have a look at another example. Here I've been given an angle and a side. I've got the opposite, that's 4 centimeters. My angle is 53.13, and I'm looking for the hypotenuse. Notice how I know it's the opposite, because it's opposite the angle I'm working with. And when we go through Oscar had a heap of apples, it will be the sine rule. The very first rule is the sine rule, and it's Oscar had opposite hypotenuse. So I'm going to work with sine x, sine the angle, is equal to opposite over hypotenuse. Well, I know my angle is 53.13, and I know the opposite is 4. So sine 53.13 is equal to 4 over whatever the hypotenuse is. I'm moving the hypotenuse upwards, and remember when the number or variable is below the 4, and remember hypotenuse, this is just a variable in the end, I move it up by multiplying both sides by that value, by the whatever the hypotenuse is. So I'm left with hypotenuse times sine 53.13 is equal to 4. Now I've got to move the sine 53.13 down to get it onto the right side, because I just want to find out what the value of hypotenuse is. So I divide both sides by sine 53.13, moving it underneath the 4. When I type in sine 53.13 on my calculator, it gives me the value of 0.8, and now I can simply do 4 divided by 0.8 is 5, just what we expected, because we knew with a Pythagoras theorem, with a triangle that's got sides of 4 and 3, the hypotenuse will be 5. So that's how to use sine, cosine and tan, how to find a missing angle and to find a missing side.